And we're up. Hey, this is EEVblog Raw. I was just assembling some microcurrents down here. Well, there they are in the back. I was assembling some microcurrents and I went live on UStream, and some people suggested I should just hit record and actually record this thing. So, oh well, here we go. It's me testing some microcurrents. Wow, great fun. And I've got the webcam and the other cam attached to the thing. Here are the microcurrent units. They're over here. Can everyone see? Yeah, everyone can probably see. I've already tested 20 of them, and I've got a total of 50 units. So let's go. Do a quick visual inspection. There it is. There's a microcurrent unit. Ta-da! And they came assembled. I get them assembled here in Melbourne. Well, here in Australia. Anyway, get them assembled in Melbourne by a guy there who assembles them in his garage, which is great. Anyway, this is the microcurrent. I get it assembled by a guy in Melbourne who assembles them out of his garage. And all I've got to do basically is pop in a battery and whack on a case, and then we're right. So it's pretty quick. The case is actually manufactured, don't know if you can see in there, manufactured in Western Australia. Beautiful. So it's got a fairly high Australian content, this thing. It's assembled, well, it's assembled here in Australia. The box is made in Australia. I then finish assembly and test it here in Australia. But unfortunately, the PCB is made in China, of course, and all the components come from the US. They come from DigiKey. There you go, dead giveaway. And I don't use any grey market parts or anything like that. They're all genuine parts, but there you go. And what I'm going to do is I'm going to assemble them in batches of 10, basically. And then I will batch test them, also in 3 stages, in batches of 10. And I find that's pretty much a good compromise between not wearing out my test gear here, having to change ranges and stuff, which I'll go into, but also but you know, it's the most efficient in terms of time and stuff like that. So that's good. One of the first tests is to make sure the battery's in and make sure the LED works. I've already fully tested a unit, so that actually proves that that the components I've got are good and all that sort of stuff. They're the correct components, they're right. And then you can just do spot testing on the units after that. You don't have to fully characterize each one. Like, I'd be crazy if I tried to characterize the full performance of each of these units. That'd be just nuts. So, and it's a pretty quick process too. I can probably I can do about 20 of these per hour. Sorry, I can assemble 20 of these per hour, and testing doesn't take that much longer either. So I haven't got an exact figure for it, but yeah, it's certainly not a long process, that's for sure. So anyway, this is EEVblog Raw. Someone suggested that I just turn the... How boring is this? My back to the camera. Sorry. And just assembling these units. Actually, let's move it over here. There you go. You can see me a bit better now. And I've got to be careful. I've got to remember to actually put the battery in. Many times I have assembled these things and I've completely forgotten to put the battery in them. So I've got to unscrew them and put the battery in, which is really annoying. So, and one of the problems is after I've finished testing them too, when I've got them all lined up over here, I've got to make sure that they're all switched off, because occasionally I have shipped a unit to somebody and they've emailed me and said, hey, you shipped it to me and it was switched on and the battery's dead. You know, oops, sorry. Yeah, I've got to be careful about that. As I mentioned before I started recording this to a couple of live people who were here at the time, they were, I mentioned that yeah, if I designed this unit again, I'd certainly put in a auto power off auto power off capability, or just give it such phenomenal battery life that it wouldn't actually matter. So anyway, I didn't, you know, there wasn't a huge amount of thought that went into the design of this thing. It's just I wanted one for my own use, so I did it. And then I thought, oh, you know, and I wanted to make it look good. Look, I didn't want it to be bodgy. And then I thought, oh yeah, I could do I could actually get it actually published in Silicon Chip as a project. That'd be neat. And so I didn't really go to town on the design. It's a very simplistic design. So there's nothing fancy in it at all. But yeah, if I was to redesign it, I would probably not use the same chip. I'd probably use a different technique. I'd probably extend it down to much lower than what it currently goes to, and I'd put in some intelligence to auto switch it off perhaps. But the thing is, you know, it's only powered from one of these little coin cell batteries. So really, if you powered it from AA's, or, you know, if you put a couple of AA's in there or something, it'd run forever, really. It'd run for many thousands of hours, continuously switched on. So you wouldn't have to worry about it. And that's one of the trade-offs with designing battery power stuff is, you know, what sort of battery life do you want out of your product? And sometimes it's better just to over-engineer the battery in it and just, you know, give it phenomenal battery life, because I think it's incredibly important for battery-powered gear to have a phenomenal battery life, be it a multimeter or be it a watch, which I'm trying to design my Mark II calculator watch again at the moment. I'm doing all sorts of things. Actually, this could be a update episode, possibly. Who wants an update on what stuff I'm working on? And I'm not looking at the screen, so I can't get anyone's answers because I can't hear anyone. So I will have to check out the chat window over there and see what's going on. Let me screw this one together and I will check out the chat window, see how many people we got, and all right. Let's see the status of the watch project. A guy standing in front of bench crafting some boxes and talks to what looks like no one. Yeah. Eagle. An electric screwdriver, yeah. See your Tronic Stuff. Tronic Stuff's gone. John from Tronic Stuff, who's a fellow Australian blogger. If you haven't checked out John's website, go to tronicstuff.com. I highly recommend it. He's got some awesome Arduino tutorials and stuff like that there. So, bit of a plug there from John, but I'm sure everyone who knows my blog will know John's blog as well, or you should. Well worth following. One of the few people out there actually producing a shitload of content. Because there's a lot of people who don't produce content on regular, on a regular basis at least. Anyways, it's probably some. I did mention that I might give a background of, well, an update of where I'm at, because I don't do update blogs anymore. I've done a couple in the past. I occasionally do it on the live shows, but what I'm working on at the moment is I want to get these µCurrent units out because people asked for them. I wasn't going to do any more because I just lost interest in them, really. But people kept asking for them, so I thought I'd do another 50. So here I am, assembling and testing 50 units. And what else am I working on? I want to do a, well, actually one of my projects is an LED matrix project. It's a little LED matrix thing. It's tiny. The other ones on the market are 4 times this size, so they're much bigger. This will be a really small LED matrix, and that's got a Atmel AVR on it. It's actually Arduino compatible, so and the whole idea is you can join them together and make bigger LED matrices and stuff like that. That's a project that's been hanging around for quite some time, and I haven't got around to finishing it, so I'd like to finish that. Open source, it'll be open source hardware, of course. Yeah, I don't know if I'll sell a kit of that or not, but I certainly want to do it for my own use. And next up, I got an interest to do my Mark II calculator watch again, and I was going to do a blog on where I was at with that, actually, showing some previous design ideas I'd come up with and stuff like that. So I might actually do that, but I think I've decided now that I want it to be a touchscreen watch. Instead of, I was going to do the same as what I did and actually have a button-based calculator, but I don't know, I probably think it should be touchscreen, and I found a nice new little touchscreen that fits. Actually, there's a problem with it. The LCD fits in the size I want. It's got a nice LCD. It does come with a touchscreen, but the touchscreen is much bigger. The touchscreen overlay is 8.9. Woohoo! The touchscreen is much bigger than the LCD itself, which is really annoying. I don't know. Can you actually cut down a touchscreen to size? I've never actually tried it or something like that. I don't know if you can. But that might be a solution anyway. So I haven't looked too hard into that, but I do want to do that. I want to do the Microwatch Mark II. I've also got a power supply, a USB based power supply, which is in a similar box to this, and it's a project which has been hanging around for more than a year. I've had prototypes of it, and but I've changed my mind a couple of times on that, so that is another project. Alright, remind me to talk about the rest of the projects. 2, 4, 6, 8, 10. There you go, do it in batch of 10. Nice round number. Why not? So, yep. There we go. Alright, time to test them. Now what I've got here is I've got a Keithley I've got a Keithley 225 current source. That's the actual number of the model, 225, and it's a really nice current source. I highly recommend that you pick one up if you're after a general purpose current source. Now I'm going to test these in 3 batches. 3 batches, because there's 3 ranges on the microcurrent itself. There's nanoamps, there's microamps, and there's milliamps. So I'm, rather than, I started out and I tested each unit individually, and then I was constantly flicking my current source through to the different ranges, and that was really annoying and time consuming, not very efficient, and it would wear out the switches on my current source, I'm sure, if I did too many. So now I just set it to 100 nanoamps, and I'm going to test the nanoamp range. So, wouldn't you know it, there you go. Yeah, I set it. I forgot to put a battery in that one. Would you read? Wouldn't read about it. Alright. These sort of things happen. Too busy yapping away. So yeah, I will test each individual current range on each unit, and you'll see just how quickly I can actually do that. It's not a slow process at all. There we go. Duh, missing battery. Alright. So, yeah, if you like this idea of this EEVblog raw, then let me know, because it's not a regular live show because I don't do the interaction with the chat window. I have no idea how many people. There, we've got 16 people, 15 guests and 16 viewers. Hey, awesome. And normally that's my live show, is a question and answer type thing. So, alright, here we go. Now we're talking. Alright. And yeah, so I've got it set to 100 nanoamps. And basically I'm measuring the input current and the output voltage here, and it should be within 0.2%, and it is, because that's what I claim for the unit, that's within 0.2. So as I do, I'll just do them all like this, and you'll see that I don't actually have to change ranges or do anything like that. I can just pop it in there, and that's it. It takes a little bit of time for this range to settle because it's quite noisy, well, you know, it can actually easily pick up noise and stuff like that because it's on the lowest current range. The other ones are a bit quicker because they're more stable, but that one's spot on. But yeah, that's pretty much how fast I can test these units. It's faster and more effective than testing one unit and then switching between the ranges and stuff like that. I find it's just easier to do 10 at a time like this. Oh, have it on the right range, that helps. Turn the power on, that helps. And that one's spot on too. And they should all be spot on because I am actually relying on the tolerance of the resistors, and I've fully tested one unit, so I know that the build is good, and they all come from the same batch of parts. So it's highly unlikely that one unit will be out of spec, although I've already found one today. That was it was 0.24%, I think it was, instead of 0.2. So I don't know what's the go with that one, but it's very rare that I actually get one that's out of spec, apart from that mix-up, which you can see in a previous video where DigiKey sent me the wrong. Well, the manufacturer sent DigiKey the wrong parts, the wrong tolerance parts, and they ended up in my microcurrent unit. So, but now I'm avoiding that by measuring the input current as well, whereas before I already had my current source already calibrated and I didn't bother measuring the input current, and that's what caused the problem. So yeah, that's good. So what I'm doing here is called spot checking. It's just spot checking. In this case, each range can go up to a volt or greater, but I tested at 0.1 volts or 100 millivolts full scale, 100 millivolts output. So if I feed in 100 nanoamps, I get 100 millivolts out here, right smack on the meter there. So, and if it's within 0.2%, then I am happy, and usually they're well within that. Well within 0.2%. Like that one is 0.04%, right? It's tiny. You know, it's quite close. So, I mean, these aren't ultra precision units, but they're precision enough. So there you go. I've just gone through and tested the first range of those. Now I'll switch it to 100 microamps, and I'll go through all 10 again. Yes, it's a bit monotonous, but this is what you got to do. Now, someone before suggested, why don't I automate this test? The reason being is just the sheer small number of units I do. Like, this is a batch of 50. As you can see, I can test these very quick, and it would take me much longer to actually design a custom test jig for this thing, some sort of bed of nails tester or something like that. It would take me longer to actually design that and build it and test it and implement it than it would to just test these units like this. Like if I was making thousands of them, if I was getting up into the thousands, then yep, I would certainly. Whoa, hang on, that one's way out. That one's 0.4% out. 0.4. Wow. There you go. Wow. All right. Well, there you go. That's 2. I'm going to put that one aside and keep going. That's pretty rare to get 2 failures out of my batch. Spot on. So yeah, if I was doing thousands of these, I would I would certainly go to the effort to do an automated jig. There's another one. What's going on here? That one's also 0.4% high. Well, there you go. Wow. All right. Something is going on there. All right, something's really happening here. I'm getting that one's 0.7% out. That one's 0.7. All right. Yep, I just had several in a row, that's all. That one's within 0.2. Wow, okay. I've got 4 so far out of this batch, so they're slightly out of tolerance. And it'd actually be very interesting, I think, to see that one's absolutely spot on to the least significant digit. I think it'd be very interesting to actually plot and graph this data and see the error histogram and see if it's actually a bell-shaped curve. I'd like to know what the shape of the curve is. I'm down to 7 units. All right. Time to go up to the milliamp range. So 100 milliamps. Bingo. I'll just do a polarity test here to make sure it works in the opposite direction. And we have a winner. That's actually a finished unit. Bingo. See? That's how quick it is. It's not that fast at all. I've got to remember to switch it off, and it's done. I've tested all 3 ranges, and I've tested the polarity, and it is sweet. Yep. Bingo. So where was I? Yes, I was talking about histograms and things, error histograms. I think it would be very interesting. I love analysing and graphing data like that. You can find some real fascinating things in engineering by just analysing data, plotting it on a graph and seeing what the curve looks like. And I do believe if you got something like this µCurrent unit, polarity on that one I think, then you would probably find it is a bell-shaped curve, the bell-shaped manufacturing curve for the tolerance of the resistors. I'm assuming, I don't know, but that's the interesting thing, to actually plot it. Or it could just be completely random. Maybe you would have to have a high enough number or something, a high enough sample number to get some meaningful data out of it, but I think it'd be fascinating. So it's one very interesting thing you can do in engineering is to plot data, and it's amazing the stuff that comes out of it. It really is. You can find some hidden phenomena that you wouldn't otherwise know. Now, one that springs to mind there is one blog I've done. If you go have a look at it, I'm not sure which number it is, but it's the one where I do the LED lighting for my back deck out there. It's probably, you know, number 70 or 60 or something like that. It's a long time ago. And if you have a look at that, I plotted the temperature data of that. I plotted the temperature rise of my LEDs, and I noted this in the video. I think I pointed it out on the graph, I think, and is that what I discovered from plotting that temperature data was that I could actually see a storm. I could actually see a storm that came through, and the wind picked up, and it actually cooled down the LEDs because I had them outside, and it cooled down the heatsink enough to change the temperature by a few degrees or something it was, and you could see the dip in it. And I correlated the exact time of that because I logged the time as well. I correlated that with the storm that came through, and it was spot on. You could actually see when the wind picked up, and the based on the weather data and stuff like that. It was absolutely fascinating. And that's a very simple thing. And there's much more fascinating stuff I've discovered in engineering over the time by just plotting that data. So there you go. I've got a whole bunch of microcurrents done there, and boy, I could keep going, but geez, I don't know. It's a bit of an effort. What's the time actually? 6 o'clock. I've got to go to the gym in 20 minutes. So, yep. Yeah, so I think I'll stop testing the microcurrent units for now, and I'll do it again later. But I was telling you about the projects I was working on. I've also got there's another project in a same box as the microcurrent. Actually there's two in the microcurrent. There's another couple of power supply projects I want to do as well, and I want to do a quadcopter design. I think I've mentioned it before, but I want to do an automated quadcopter which flies through a canyon, and no one's ever done it before as far as I'm aware of, and so I want to get into doing a quadcopter. And then just last night I had the idea, extremely foolish idea, that I would attempt to build an open source pick and place machine. Oh yes. The amazing headless Dave. Am I headless? No, I'm not. There's the webcam. Yeah, I was searching eBay, and I came across these feeder reels for the component reels. And one of the hardest aspects of pick and place machines, and why I don't think anyone has done one yet as any viable one as an open source project, is because of the feeders. There's some dust on that. Is the feeders. Like, all the components come on reels like this. Okay, they actually come on reels, and you have to feed the tape. We've got a loose. Yeah, here we go. Here's a loose one. And you've got to feed the tape through, so you have to put the reel in some sort of holder, and then the tape's got to come out, and then the component has to, and then you've got to peel back the tape on the back of it. But that's real easy. You just attach it to a thing, and then a sprocket. They've got little holes in them like that along the bottom, and you've got to have like a sprocket or some other system that pulls it through, and then it turns as it pulls through, and then the pick and place arm's got to come down, and it's got to locate the individual component by visual, usually by visual ID, and then it's got to turn on the suction, lift it up, move it over to the board, put it down. So, but you've got to have, like, to make a useful pick and place machine, you can't just have one reel or something like that. You've got to have like 20 reels, because, you know, even a simple board like my µCurrent's got, I don't know, at least probably 10 different components on it, so you'd have to have a pick and place machine that supported 10 reels. Otherwise, you've got to run all your boards through once, place all your components, and then take off all those reels, and then put the other components back on the reels, and then run it through again. And then if you've only got, say, 5 and you've got 50 components on your board, you've got to run your board through 10 times. It's crazy. So anyway, I found on eBay, they've got these cheap little holders for these, like some sort of manual thing to hold these pick and place reels in place like that. And they've got like a little channel that comes out, and they've got a little bar which can hold back the tape and everything. And it was cheap and it looked simple, and I thought, well, how hard is it to add a little stepper motor to that to pull this through like that? And you know, I don't know, I got tempted into thinking it didn't look overly hard to actually come up with a solution for an open source pick and place machine. But I know it's not going to be that easy, but I was just tempted, and I still am. So I don't know, you might see me spending the rest of my life working on an open source pick and place machine, but geez, it's a lot of work. I don't know, my quadcopter is going to be enough work compared to an open source pick and place. So and I was talking to people before about these bits of gear here. These Keithley, zoom in. These Keithley current sources. I'm going to have to do a blog. I was just going to do like a teardown of these. Now, if you're after, sorry for the live people, I can't zoom in any better than that, but the recorded people are going to get it. Now, I've actually got 4 of these Keithley instruments. One's down there. This is a Pico amp current source. It's a Keithley model 261. So if you want to generate very low currents, this one can go down to 10 femto amps. That's femto, okay? That's one engineering unit lower than pico, okay? It goes, you know, milli, micro, nano, pico, femto. 10 pico amps, so I can adjust that 10 femto amps, 20 femto amps, 30 femto amps, etc. It's a brilliant, absolutely brilliant unit. And because, yeah, there it is. You've got 10 to the power minus 12, right, which is pico, and then you've got 2 decimal places beyond the pico. So 10 femto amps, incredible. But it only goes up to a maximum of 10 microamps or something. No, 100 microamps. Sorry. So it's designed for really low currents, but very handy if you have to generate incredibly low currents in the order of picoamps or femtoamps. But a more usable one will be this Keithley 225. That's the model number, 225 current source. And it only goes down to 0.1 nano amps, okay? So it only goes down to 100 picoamps, but it can go up to 100 milliamps, okay? So it's a more usable current source. So if you check out one of those on eBay, if you're after a really versatile current source, I highly recommend that one. And then here I've got a high voltage power supply. It's a Keithley model 240A, and it can generate anything from 1 volt up to 1,000 volts, or 1,100 actually, sorry. It can go anywhere up to 1,100 volts, and that's quite useful. And down here, I will do a teardown of these, but I was really tempted to get this one too, because I wanted to complete the set, if you know what I mean. You know, so I've got this, which is a Keithley 260, model 260 nanovolt source. So it can go down to, sorry, I don't remember the the exact, I think it can go to, yeah, it can go down to 10 picovolts, I think. So 0.01 picovolt, 0.01 nanovolt. So it's a nanovolt source. And don't ask me why you would want a nanoamp, a nanovolt source. But anyway, so in the EEVblog lab here, I can generate anything from, you know, in the order of picovolts up to 1100 volts over the whole range, and anywhere from femtoamps right up to milliamps. I don't actually have a constant current source for, well, no, your regular lab power supplies can generate constant currents. Your regular bench power supply can generate constant currents up to the order of amps. So I can cover this massive range of test signals. And anyway, these bits of Keithley gear are really good. I highly recommend you pick them up. I think one of them uses tubes. I think the high voltage power supply's got a tube in it. Anyway, I'll have to do a separate teardown of those, but these are just really useful instruments to have. So if you can pick one up cheaply on eBay, I highly recommend it. They're really good, and even after all this time, I don't know what vintage they are. Probably you know, 80s or something vintage at best. So they're I'm not sure how long they sold them for, but they're really well made. You can get the service manuals for them, and they're really quite nice. So highly recommend you pick them up. So there you go. That's EEVblog Raw. I should probably call it quits, and that's it. So if you like the Raw, it's not a regular live show, it's just me doing whatever in the lab. Today it was building microcurrent units, and there they are. Aren't they beautiful? Oh, all lined up there. Look, it's lovely. Just absolutely beautiful. Anyway, that's it. I'll catch you later.